So to the examples. First thing I want to note is when might you use rearranging and taking square roots as a way of solving for or I guess finding the solutions for quadratic equations. Here are the times when you would use rearranging or taking square roots. First is when the equation is in vertex form. So we're familiar with vertex form. Vertex form looks like this: y equals a x minus h all squared plus k. So the reason that we would choose to use rearranging and square rooting when we have vertex form is because our variable that we would be looking to solve is in one spot only. It's nestled inside this bracket. So when we have x's in multiple places, it's much harder to use rearranging and square rooting as a method of finding solutions. So this is one of them. The second is when the equation is in standard form with no bx term. So if you can imagine, our standard form would look like this: y equals a x squared plus bx plus c. And we're saying imagine there's no bx term. So all of a sudden what you're left with is this nice little equation where, again, we have our variable that we're looking for, x, in only one location. So I guess the takeaway from this is when your x is in only one spot in your quadratic equation, that's a suitable time to use rearranging and square rooting. Procedurally, how do we figure this out? Well, let's look at the first example and we'll work it through. So I typically model this by saying, so there's our variable, x. What's happening to x? It's currently being squared. So how do we go about undoing the squaring of x? We would square root. So we're going to do the same thing to both sides of the equations. That will result in x being equal to plus or minus 5. Now normally in the class we would talk about why plus and minus 5 makes this true, why you need to consider both solutions. We're not going to have a discussion about it since you're not really here with me, but I will say that if you consider as proof of this concept being true that 5 squared will indeed give you 25, which is the value we started with, but negative 5 squared will also give us 25. So which of those two values is correct? They're both correct. And in terms of, if you could imagine how this was going to look, if we were to graph this and imagine that we were to have an input-output variable, i.e. if we were creating a quadratic function here, it would look something like this. Very loosely something like this, where our vertex would be down at negative 25, and we would have two x-intercepts, one at positive 5 and one at negative 5. So this jives with what we know about quadratics, so it's completely reasonable for there to be two solutions here. Hopefully that explanation works for you. Let's have a look at the second example. So we have 2x squared equals 98. So again, the question I ask myself is, where's my variable and what's happening to it? Well, two things are happening to it at this moment. It's being squared and it's being multiplied by 2. So in terms of how to deal with this, I need to undo two operations. What is the correct order to undo those two operations in? I do want to make a note right here that we are going to be following BEDMAS backwards, which means that we are going to undo all of the addition and subtraction before we undo the multiplying, dividing, before we undo the exponents, and before we undo the brackets. So if we follow BEDMAS backwards, and we recognize that in this particular question, x is being both squared and multiplied by 2, we're going to undo the multiply by 2 first by dividing both sides of our equation by 2. That's going to result in x squared being equal to 49. At this point, we have to undo the squaring, which we do by square rooting both sides. And once we've square rooted both sides, we find that x is equal to plus or minus 7. Now, people typically in class ask, is it important that I write down the positive and negative in front of the 7? And the answer is absolutely, because as I showed you in the last example here, if you only put down positive 5, you're really ignoring the other whole solution on this side. You're basically getting rid of this guy over here. Well, apparently end the whole line. So if we get rid of just that little guy there, we have half the solutions. That's half the correct answers for this question. So is the plus minus important? Yes, because it's taking away half of the actual solutions to the question. Let's look at x squared plus 64. So there's our variable. What's happening to our variable? It's being squared and added to 64. If we're going to follow BEDMAS backwards, then what we should be doing first is undoing the addition and subtraction. So we are going to subtract 64 from both sides of our equation. That's going to result in x squared being equal to negative 64. And now we undo the squaring by square rooting both sides of our equation. And here's a problem. Taking the square root of a negative value is not something that in our grade 11 University College math course we're going to tackle. If you were in 11U, this would be our gateway into imaginary or complex numbers. We're not going to go down that road. So for us, this means that there are no real solutions. And the reason I've included the word real in here is because there are imaginary solutions to this question that, as I said, we're not going to get into. But if we start to learn that terminology, the difference between real and imaginary numbers, depending on where your math trajectory takes you, this might be a time when you remember we talked about real solutions and there will be imaginary solutions at some point in your math future, possibly. So how might this look? What this looks like in terms of a graph would again be something like this, where you have a vertex above the x-axis and our parabola opens up. So it makes sense that there are no real solutions because our parabola, were this to be a quadratic function, would not have any x-intercepts. So again, hopefully we can start to see the connections between these two concepts, the concept between or the concept of quadratic functions versus quadratic equations and how they connect. We're going to skip over this example. Again, we're just trying to find what's happening. We're adding layers of complexity here. So if our variable here is x, we have x being squared multiplied by 9 and subtracted from 16, or having 16 subtracted from it. We would undo this by following opposite operations. We add 16, we divide by 9, then we square root, resulting in a plus or minus. But I do want to go on to show you that sometimes, I will find one here. Let's start with this one here. When we're trying to find our variable, we recognize that there are three things happening to it. It's being subtracted by 2, it's being squared, and it's having 9 added to it. But I want to point out that if we're following BEDMAS backwards, undoing plus 9 first makes the most sense because that's undoing addition subtraction. But that negative 2, or subtract 2 inside the brackets, that's a brackets. That's going to be the very last thing that we consider. So let's work this example through. I'm going to subtract 9 from both sides of my equation in trying to isolate my variable x. That's going to result in x minus 2 all squared equals 16. And now the next thing I have to do if I'm following BEDMAS backwards to isolate my variable is to take the square root of this. And that's going to result in x minus 2 essentially becoming free of its bracketing and being squared. And over here we have a plus minus 4. Now, at this point, we have sort of a divergence happening. We have one situation where we know that x minus 2 will be equal to positive 4, but we have another scenario where x minus 2 will be equal to negative 4. Both of these are going to result in correct answers. We need to work each of these scenarios out. So in this first scenario, we are going to undo subtract 2 by adding 2 to both sides. That will result in x being equal to 6. And in our second example, we are going to undo negative 2 by adding 2 to both sides. And that will give us a second value of x being equal to negative 2. So in this particular case, the two answers are not identical as they were in some of the examples we worked on above where we had plus minus 5 or plus minus 7. This one, there are two distinct answers. And again, if you can imagine what this means, what this would mean to us in terms of graphing would just be that our parabola would be just a little bit sort of off center from the y-axis. you can get a -2 and you can get a +6 as your x-intercept. So again, there are two answers. It just so happens in ones that have these bracketed beginnings, so this one over here, again, will also have two answers, but they will also be different. So hopefully this explanation helps. There's a worksheet to follow this lesson. If you have any questions, you can feel free to email me. Otherwise, hopefully this explanation helped, and we'll head on to lesson 2 shortly.